Good morning, everyone. As you can tell from the middle part of the slide, my name is Steve, and as you can tell from this part of the slide, I'm a little bit of a geek. Today I shall be talking about a little thing that I was doing to re-implement one program in several different languages. So, it's the same algorithm, but different languages, because I just wanted to see what was actually different about them. I programmed several languages, and I was just kind of needed to refresh my memory. Why is it I'm programming this particular language? Because they're paying me. Why am I using this particular language? Because it's fun. But actually looking at it slightly objectively, I had a little more insight than I did when I was actually working on it properly. So, over the course of the next 20 minutes or so, I'm going to be talking about this idea, implementing one algorithm several times in different languages. There's going to be some code samples. You're not expected to read them. You can find them from the website if you're that interested. The interesting thing is about the shape and of the code and the bits that I'll be telling you alongside it. We're looking at the differences, the connections, and a little bit about what I discovered throughout the journey. So I suppose the big question is why? Well, in 2015, it was the 200th anniversary of Ada Lovelace's birth. And this was the very first computer program. Technically, it really wasn't. It was an algorithm. But she created the algorithm, and it's become known as the first program. So I thought, why not? I will re-implement whatever this thing is in a few languages. Who recognizes this? Yes, of course you will. Well, it calculates Bernoulli numbers. And Bernoulli numbers are very useful and very important for a lot of people smarter than I am. They do trigonometric functions, number theory, and analysis. All stuff I have no idea about because I messed up my maths exam, but it produces this row of numbers at the top, and I understand fractions, so I thought, I can do this. The method of computing numbers which I chose to use was the Akiyama-Tanagawa algorithm, which I know because it's on my screen and no other reason. And what it does is you have a series of fractions. They're going 1, 1/2, 1/3, 1/4, 1/5. You get the pattern. And then by subtracting the number on the right from the number on the left, it produces the number underneath. So 1 minus a half is a half, and then you do a third minus a half, which is 2/3, and so on. So the 0th Bernoulli number is 1. The first Bernoulli number is 1/2. The second is 1/6, following down on the left-hand side. Which means to compute the 10th Bernoulli number, you obviously have to compute the 9 before it. I'm not worried about optimizing the algorithm at this point, just computing the algorithm at this point. And I called it Ada 99 in honor of Ada Lovelace. So the first off, I decided to do it in JavaScript. I was doing a lot of JavaScript at the time, and JavaScript is good. Normally I get a boo at that point. I'm quite impressed. And this was the JavaScript I wrote. As you can tell, it's incomprehensible because my Perl roots have never gone away. Obviously, I didn't write it quite like this in the first instance. I actually wrote it slightly more sensibly like this. Again, you're not expected to be able to read the code. It's all online. But what you can see is there's a couple of loops here. Obviously, for the 4th Bernoulli number, we go through the loop 4 times. And inside that loop, there's another one that does all the subtract this fraction, subtract that fraction, subtract that fraction. Nothing too complex there. Being subtracting fractions, you've got to multiply the bottom by the top and cross and all that sort of rubbish we learn at school. But it is advantageous because it means I can actually go back to my maths teacher when I was 11 and say, Mr. Sangwell, I have finally used this information in real life. Nothing else in my maths I've ever used. So that's for Mr. Sangwell. And then my mate Bob said, I posted this up on Facebook with my 4.5 friends, and Bob, who happens to be one of those 4.5 friends, says, you know what you should do? You should do it in Ada. After all, it's her algorithm, it's her first program, you should probably do it. I thought, well, I don't know Ada, but I'll learn it in a lunchtime, and I wrote that. Which is probably not idiomatic Ada, but it works. It's a bit bigger, as you can see, from the JavaScript version, and that's to be understandable. You can see a few bits in there, which you don't have to worry about in JavaScript. Notably, you've got a lot of strict typing. You've got semicolons to end lines, just like C does. Fantastic invention, that one. Double dot ellipses. Before Perl and Ruby, Ada was doing this back in 1980. So it wasn't a new idea then. I'm sure the people that come up with Ada kind of, had stolen it from somewhere else. You're separating the declaring of variables from defining them, which is something which is fairly common in some languages and fairly common in others. And I never really stopped to think, should you have to declare before you use? Is that really necessary in all cases? Sometimes it's really beneficial to say, oh, I just need something right now. Arrays used these type of brackets. Some languages still do, I think. But I'm so used to the square bracket to bracket kind of arrangement that I had to really struggle to get my head around the idea that this is not a function call. An assignment is different to comparison. I know, this is PowerPoint karaoke at the moment. This one, yeah, we have a lot of assignments being different comparisons. Equals, double equals, using EQ, all that sort of thing. But at the time, this was probably quite revolutionary. The first programming language, which I consider a proper programming language, was APL, invented in 1957, first properly published in 1962, and 3 people I think are still nodding, so they've probably heard of it, or at least used it. APL had basically about 47 different characters for the different operations. This means you don't need to do this stuff about using 2 different symbols combined into one. Because as soon as you do that, you get the C problem of, did I mean A equals as assignment or A equals for comparison? You've got the same symbol being used in different places, so it's the context. If the context doesn't matter, like it did in an APL, you suddenly realize that each symbol means something different, so there's no way the human or the machine can misunderstand it. This was one of the first times I saw, chronologically speaking, oh, here we go again, that you had to use 2 symbols to create one operator. And it was using slash equals instead of not equals, or this basic bracket thing for not. And it's like, oh, I'd never seen that before in any other language.
Lisp does it.
Lisp does it. Lisp would. Oh, when I said the title of the talk, all languages are created equally, yeah, I'm in equal opportunities. I hate all languages equally. So that was the end. I did my JavaScript. I did A to keep Bob happy, and that was it. Done. Yeah, of course it's not. Otherwise, it'd be a very short talk. So I get asked from recruiters occasionally, what languages can you do? I mean, I also get asked for a CV when they've contacted me through LinkedIn, but that's another problem. What languages have I actually used in my day-to-day life? Well, I've been paid to use these ones. I know surprises me as well. I've also used these ones for fun. Yes, assembler, for fun. I'm that old. And I've invented a few of my own languages. So I have mucked around with languages, and I'm thinking, I wonder if I could do it in all of them. So, when you have an idea that sounds really good at the time, and later on, you're regretting it. So I thought, in no particular order, I will just go through various languages where if I've got a few hours to spare, I'll just have a faff around, see what I can do. So I looked at Pascal. Anyone else had to do Pascal? Oh boy. Anyone else had to learn from the book Oh Pascal? No, just me then, okay. But this was Pascal. Again, it's very formal. You've got begin and end blocks that each require an entire line, none of this silly brace stuff, or just assume it's the end of the line. Different words for procedures and functions, whether, one for returning stuff, one not. Do we really need a different word for those? Could you not just say, well, a function is something that just doesn't return stuff and don't call it procedure? Maybe. You have to put everything ahead, like you do in a C header file. You have to include all your procedures and functions beforehand and then use them later. Very C-like. You notice this, a lot of programmers who design programming languages say, oh, I don't like this programming language. I'm going to build something better. And then they incorporate a whole load of things from the other language that they're used to, which sometimes are not necessarily the things they should have left that stuff behind. Anyone that uses a language that has printf in it, I'm looking at you. So yeah, it's obviously verbose, but nowadays we don't care. We have enough disk space. We don't have to worry about using 5 letters instead of just one for begin rather than just an opening brace. It's fine, we've got that space. Declarative use, yeah, I can live with that. Loops need down to if you're decrementing a count. That really annoyed me. I'm just so used to saying, if I'm going from value A to value B, and I want to go in steps of C, I would like to say loop from A to B, changing the loop counter by C at each iteration. But if you happen to have an iteration that wants to go down, you've got to use a completely different programmatical structure to do it. If step is less than 0, do a down 2 loop, else do a normal loop. That to me just seemed weird. Different operators for the integer and double division, which actually seems quite sensible, because it does change the way you think about the mathematics you can actually be applying. So I kind of liked that. Functions versus procedures I obviously didn't, and loops are inclusive of both the beginning and the end point. As an erstwhile C program, that really annoyed me. Perl 5. Anyone here done any Perl 5? Just making sure I'm in the right room, that's all. So yeah, I mean, I hacked this up. First time I thought, oh yeah, I'll bring in the math functions because it gives me fractions. Why not? It's simple enough. And some of you who are Perl historians that have been using it for years will notice that I'm probably programming as a Perl program would have done about 10 years ago. I've not really done proper professional Perl in well over 10 years. I mean, at that point, I was writing a C++ parser in Perl using regexes. I mean, if you're doing C++ parsers, you made a career mistake. If you're doing it in Perl, you've made a real bad life choice. And if you're choosing to use regexes to do all of this, yeah, there's a reason you didn't get another Perl job after that. But this is probably about 10 years ago style of Perl, but it worked, and it just did it. And I thought, okay, I'm happy. I remembered this stuff. It didn't break. It was all fine. I should do Perl 6. Nah, forget it. I'll do it next year. Then I thought, okay, another one of the famous P languages, I'll use PHP. And I thought I'll use a library. They have one called Math Fraction and Math Fraction Op. And there was a bug in it. PHP gets a really bad reputation. And for most of the time, it really shouldn't. It's the PHP programmers that probably should get the bad reputation, or the PHP documentation writers that should have the problem. But for the most part, as a language, it kind of hangs together. And I've written a few websites in PHP. I've 20,000 lines of the stuff, so I've not hit that many problems. But then I write 20 lines to do a mathematics problem, and I hit a problem. And I think, yeah, you're right. There's something wrong here. And it was in those 2 lines where all these other functions returned pointers rather than references, and in this one odd little case I decided to not do it. So you had to break out one operation into 3. And I thought, well, I've done it now. Problem solved. Who remembers BASIC? Who recognises this form of BASIC? And which of you are people who decided that Commodore 64 was the right choice? Yeah, I think there's some people over there who would like a word later. This is Spectrum Basic. And yeah, I never thought I'd been talking about Spectrum Basic in 2017 either, let alone programming in the darn thing. And this is the binary calculation for Spectrum Basic.
Did you program on an actual Spectrum?
I have done. I grabbed these from an emulator. I have 4 Spectrums, I think, currently. I'm currently connecting them up to an Arduino as one of the side bits. If anyone wants to talk retro computing and digital heritage, that's another talk. But I'd written it in BASIC, and there's a few things I'd forgotten about Spectrum Basic, other than the fact it worked very slowly. I had to run this for about a day to get this far. There are no local variables. There are in some basics, but this one, on Spectrum Basic, there are no local variables. You know, it's like having to return something from a function and having to set it into a global variable, then read it out of a global variable the other side. It's rather annoying after a while. There's no recursion in it, partly because there's no local variables, and partly because when they wrote Sinclair Basic, they'd only got 16K to ram all this stuff in, so they didn't bother with it. Computing binary numbers, at one point you've got fractions, so you want to reduce the fractions. Reducing fractions use the greatest common denominator function, which is inherently recursive. I now had to do an iterative version of a recursive function that I'd not done since computer science days at university. It's the only time I've ever had to convert a recursive function into an iterative one in real life. Because again, I've got local variables, so I've got to compute this stuff iteratively and then return the results in a global variable to the function that didn't want it in the first place. And I didn't manage to do that without goto. Yeah, well, no, I couldn't. Had to use go_sub, no gotos, except in other loops. 0 divided by 0 sometimes equals 0. Sometimes it crashes. Depends on the version of BASIC. Loops and arrays start from 1. I mean, Ada also likes to start its arrays from 1 as well. And I was reading an issue of Debug magazine about BBC microcomputers. And in there, they talk about, and this program, it works well, but they're starting their arrays from 0. This is something I hope never catches on, and the sooner as we lose this barbaric practice and index our arrays from 1, the better computers will be. Yeah, they got that bit wrong, didn't they? They liked gate post errors in those days, obviously. I also used another version of BASIC called Amos. Anyone for Amos? Amiga BASIC, originated from STOS, or the ST. There, instead of returning a value from the function, it would set a global variable called param. This was in 1991. So between the Spectrum in 82 and 1991, no one had learned that setting global variables for your return types was a bad idea. And if anyone wants to tweet anything, this is the pithy one-liner that will be really quite nice to tweet. Was it ever really used for teaching programming? Looking at all the things that BASIC does, did it really teach programming? Or did this really introduce it to people?
It did teach programming as it was practiced at the time. It was the teaching version of Fortran.
I'll come back to that if there's time for Q&A. So I then decided this is a mathematics problem. Mathematics problems obviously should be solved in Bash. And this is what it does. And it works. But seriously, look at what you have to do. To do the basic of let's multiply a couple of numbers together, you've got to do it to a temporary with a double bracket thing around, do another temporary calculation calling the expression of with all this stuff with a dollar and a brace and then another color brace, that's backslash star, because otherwise it'll just glob everything into it, and then something else, and then, oh boy. But yeah, it worked. Never again. I went back to C. C was my second proper programming language after 3 different assemblers and BASIC. And I thought, oh yeah, I'll remind myself of what it's like to do proper C. I've done C++ since then, but I'll do it proper C. So I'm not using the STL. I've got no boost stuff. I've got to use malloc free instead of new and allowing the destructor to automatically destroy my objects. I've got to use types, and I'm never going to complain about C++ and all that. If you complain about the verbosity of C++, its templates, go back to proper C, and you'll suddenly realize why they're all there. So I did this in 20 other languages. Now I'm up to 24, 26 different languages I've done this in. Can't program in properly in anything, to be fair. So the old and new ideas, they're never struck. People have old ideas. They think, yeah, this is really great. And people say, no, you should really leave that stuff behind now. We don't do it that way. And then a language comes along, like Amos later on, and they repeat all those same mistakes. Array 0 again. Good eyes get stolen eventually. Use strict, which is good for this room particularly. I have a t-shirt at home that says Perl is my bitch on the front, and on the back it says use strict. Wore that for ages, still do occasionally, because I can fit into it, believe it or not. This was used by JavaScript a number of years ago. JavaScript started having use script, and it would suddenly do a little more error checking. I say a little more error checking. There was 0 error checking before. Now there is some, so that's an infinite % increase, I suppose. And they used it, and they never admitted where they got it from. If you're watching YouTube, gotcha. Scope, no one knows what scope's meant to be. Do we do it between the braces? Do we hoist it if it's inside the braces it can come out? If we're dealing with closures, do you force people to pass the variables you want to be closed inside? In C++ 11 and 14, you have to explicitly say, I would like this part of my environment enclosed into the closure, into the lambda that I'm calling. You have to do it explicitly. Is that necessary? Should we actually say, no, you expect it to be local at this point. As a programmer, you think, it's in the scope, it's between the braces, I should have it. But some languages say not. Can names be reused between vars and methods? Sometimes you can quite happily call a variable main and your method main. Some languages don't like that. Maybe we should invent a new language where that's not possible. Nomenclature. Enumeration, I thought, was a fairly common word for, enumerating things. But apparently comprehensions is a much better word. Particularly if you're designing a language you don't want other people to use because you want to appear morally superior. I can't think why I gravitated to Perl with an idea of morally superior, can you? So transpiling, that's my new amusement. CoffeeScript seems to be for people that couldn't learn the vagaries of JavaScript, but it works and it does fix the problems. So are we going to end up with a case where we don't actually program in a language anymore? We just transpile to the language we need on the target? I mean, back in my day, I mean, not everyone's quite as old as I am. In my day, we never had a language environment. You would build your compiler code and it would run on the operating system. It would talk to the operating system. It didn't need a language runtime to do anything. Now, pretty much every language needs a runtime. That's what we used to have as an operating system, and now it's part of the language. And that's not necessarily a bad thing. It's just a thing. I mean, Java has had this for years. Java as a language is tiny. It's just that if you don't know the 47,000 modules you've got to import to get it to do anything useful, Java is just nothing. And finally, some languages are patch languages. And by this, I mean Subversion. Now, no one, except for me, probably still has a Subversion server running. I've got some heritage stuff for a start. But Subversion was never built to be the source control unit. I remember the pains of CVS. I even remember the pains of RCS. And I've used Visual Source Safe. I know, I did something wrong, I tell you. But Subversion was better than them. It was never the end goal for source control. But it was better than CVS, and it was better than RCS. So that was a patch source control. Some of these languages are quite obviously only going to be there as a patch language to bootstrap something that's going to be better in the future. That's probably another tweetable one-liner as well, quite pithy. Also, I discovered some things about myself, other than the fact I'd made very many career mistakes in the choice of languages I'd used. When I started coding in C rather than C++, I started adopting all the old styles that I did back when I was coding C. So I would use the uppercase at the beginning of a variable, rather than camel case. Which was strange, but that's how I started doing C. Get result would be uppercase G, and I suddenly started doing that. When I did on Amos, Amos came with an IDE. Naturally, I started hitting all the right keys, even though I've not used it for 20 years. I can't tell you what the key on Amos is to run the program. But when it loaded up, I just instantly knew where my fingers had to go. And algorithms improves as realization sets in. You kind of get this suddenly realization. It's like, actually, why am I computing this into a temporary? I don't need to do that because it gets lost on the next loop round. Things you don't realize first time round. And naming things is still hard. That's why I went through about 4 iterations of the name of this talk before settling on an Animal Farm quote. So even if you don't like the talk, you can applaud for all the people who actually paid for this today. And I will say, and thank you, good night. And if there's any questions, I will take them. If there's time, that is. Timekeeper will tell me not. I've got time for one question, but I may be around later as well. I should be around later anyway if there's questions later on. But yeah, I've got time for one quick question from anyone. Nope, and the answer to your question is going to be longer, but yeah, there's one at the back.
Have you tried Cornshell rather than Bash with Max?
No, I haven't. You could always, there is a site called Rosetta Code where they have the one algorithm implemented in so many different ways. They might have Cornshell on it, if not, you can submit. I've submitted half of this stuff to there already. They've got some of the languages I've done. They didn't have fourth, so I submitted my fourth version to Rosetta. Yeah. On the other point, slightly drifting on from that because there's no other questions and I've got 30 seconds. I also realized halfway through writing the fourth version that algorithm for solving that problem is not the best algorithm in that language. In fourth, it's horrible. Fourth is fantastic as a language, but that algorithm really sucks in it. So sometimes you just have to go step back and go, I'm just going to rebuild it. So that probably definitely is that time up. I'll take this one offline because I think we're going to get kicked out. But no, thank you.